And just test speaker and microphone.
Okay. Yeah.
So your sound now comes from there.
Okay. Laura, thank you. Received.
Não. Oh, caraças. Peraí. Será?
It was looking fine a few moments ago, you know, just switched.
It was not my computer.
You know, like 1 minute ago, it looked fine, and then just automatically switched off.
Não, deixa ficar como está.
Maybe just reconnect it. Usually, yes. Turning it off is on again.
Deixa lá mudar isto. Ok. So
Definitely the best solution. Okay, there are two important announcements. I was waiting for the rest of the people to arrive. So the first important announcement is the banquet this evening. So you can take a picture of the QR code, and you will get then the directions to go to the banquet place. It will be in Casa do Alentejo. So this bold here is the text. Sorry, the name of the place, the name of the restaurant. Okay. So do you all have this? Did you already? Yeah. So the second. There are too many things. Me. So this will be at 8. at 8 o'clock, the banquet, okay, this evening. So there are a couple of changes in the program. So tomorrow morning, to let you recover from all the tea that you will have at the banquet, you will have the free morning until 11. Okay. And then this talk will be the same as planned. So Jeff Dalton's talk here tomorrow morning. The one in medical IR moved to Friday morning. Okay. And Asia's talk on fairness and interpretability moved to Thursday afternoon. Okay, so the whole afternoon will be dedicated to bias, fairness, and interpretability in our domains. Okay, the multimedia IR talk was cancelled. The lecturer cannot give the talk. Okay, so just any comments, questions? So on Friday, we have the same schedule, but the topic of the talk is the one from Thursday, the medical IR. Okay? So the only talk that was cancelled was the multimedia IR. All the rest is the same. Okay? Good. So if you have any questions, you can contact me or Bruno, David, or so your colleagues back there. Okay. And so the rest of the afternoon is just as planned. Okay. So thank you. This was the only notice that I wanted to let you know. Ingo.
Okay. Should have most of the talks now. Can I get this here? Oh, it's this video now or that video? Which one? It's that one now. Okay. That's our presentation.
Okay, so welcome everyone to Fdia 2022, a very quick introduction, and then I give the floor to you to present your work. So this event, Ingo, how do I go to next page? There we are. Yeah. So it's organized by my colleague Ingo and Yasha, who unfortunately can't make it today. And we wouldn't have been able to do this without the support of the general chairs of ESSIR and Zhao, Bruno, and Pablo. And of course, our PC members who reviewed your papers with a very short notice. And thank you very much to all of their support. And of course, Fdia, as you may know, it started from 2007, and it has been running for many years. And this is a remarkable 10th edition of this PhD symposium. And so welcome to you. And that's a list of most of the events we're running with in conjunction with the ESSIR, but there are a couple of them more not. And the aim of this event is really to give an opportunity to early stage PhD students and early stage researchers who can actually network with others and share your research, your ideas, and get feedback from peers and senior staff, as well as providing your own feedback to others. At the same time, perhaps this is the first time for many of you to present in front of a large audience. So it's a good practice, basically. Okay. So this event, we're running it as a hybrid. We have people joining online, giving talks online, and we have people hopefully will ask questions through Twitter account. Ingo's monitoring it.
Fdia2022.
Okay. We have 11. Yeah. We have 11 papers who's going to presenting today. There is also a lightning talk at the end. So whoever wanted to give a brief introduction about your research and want to get some feedback, please do feel free to pop up and give a couple of minutes summary of your work, and then we can give feedback or discuss the idea. And there's also a sort of soft mentoring system we are running. We have senior staff here and also peers. If you do need to talk to us or continually talking to us later on about your research, we are happy to discuss, okay? And the proceedings will be published at the open access workshop proceedings later. There are 2 sessions. We're running the first session. We have 6 presentations. Apparently, there are 5 of them are in person and 1 online. And then we have a coffee break after that. We have 5 papers, 5 presentations. And 1 is online as well. And then our lightning talks and the closing. So that's it from us.
To share the screen, I forgot that. Stop. Okay, so the screen is shared now. So yeah, first talk, Tim. Yeah, I received your slides. Let me just open them.
The timing plan is about 7 minutes per talk, and then we give 8 minutes for
Which one was
questions.
yours?
Exposure German.
First one, that one, yeah. All right, stage is yours.
Right, very good. Thank you very much.
So the camera is here.
Okay.
Although, yeah.
Yeah, I'll be in front of the screen. I have to maneuver back and forth, I guess, to stay within the camera and to be able to click the next slide as well. By the way, I'll be presenting my short paper, Exposure Gerrymandering, Search Engine Manipulation Flying on the Parents' Radar, which sort of scans as keyword salad, and it is in a way, but I hope to be able to take you through the keywords and to be able to explain to you what is meant by them. Now to find the next slide button. Oh, that was a little slide. 1 slide at a time, planning. So in order to see the keywords pass by, first of all, why are we doing this research, which is the search engine manipulation effect. Then we need some introduction of fairness. Tomorrow there will be people here who can do a lot better on that than me, but unfortunately I presented before them rather than after them, so I have to give a quick introduction here. Then my contribution, which is the notion of exposure gerrymandering, and from there we'll see where we end up. So we start at the search engine manipulation effect, which is research done in 2013 by Epstein et al. Which shows pretty much that if you give voters heavily biased search results, it can influence their voter behavior. This can even be hidden from the users if you give them some fairly unnuanced mixing. So the conditions that were given them, right? We gave voters in the for the Australian election results that were either entirely pro one candidate and the other results were entirely at the tail end of the results, or the other way around. And there's a little bit of masking with like one result from the other guy thrown in. And in conditions D and E, the users were not able to tell that there was manipulation going on. They simply thought one candidate was a lot better than the other. This can be seen as undesirable. want my search engine to at least not have political influence going under the system. This is something manipulative, in my opinion, and we should be able to do something about this. One other note came from this study is that the susceptibility to this kind of manipulation varies wildly among demographics. So the more you knew about the candidates already, the more susceptible you were to this kind of manipulation. Also with age, this is a thing that varies. So really, if you were able to target the people that were most susceptible to this in whatever way, you got the highest results. Now, given that the users are not able to tell if they're being manipulated, we hope there'll be an automated way where we can judge this with some kind of model, something along the lines of fairness. And if they can at least tell that we're being manipulated, there's no problem anymore, we just do that. So for a quick introduction on fairness as it's typically done within this field, or at least in this subpart, we have this large box model, which is not quite a black box. We understand quite a bit about it these days. We have a set of attributes being fed into the model, one of which is a sensitive attribute, which is the attribute we do not want to discriminate on in whichever way. The other attributes are fine to do. And then in the end, it presents some kind of score. The score can be anything. In our field, it's typically a ranking. And then we are talking about exposure. And then the main thing that's going on here is that we want the score at the tail end not to be dependent on this attribute here. So a naive tries to erase this arrow, but then we can still find it with proxy. There are more involved tries. This is the general intuition. So we want the score at the end to be independent of the attribute at the start. The attribute here will be political lean, since we're trying to manipulate an election. So let's build our manipulated system. We want those that are most susceptible and sort of swing voters. Research is most applicable to the United States election, where elections are really dependent on quite small margins in quite few districts. So if we're able to target just those voters, and there's not actually so much manipulation going on to the system. So you have a relatively tiny bar here. We're going to show them the red results, and then they'll vote red more, which is good. You're team red. But now fairness complains in many ways. So there is a bias towards red. There's no counter bias towards blue anywhere. So we should, if we want to build the system so that fairness doesn't notice, we need to add some blue somewhere. So in order to not lose too much utility, we just show the people who are already going to vote for Team Blue some blue results. They're happy to see it. It's their party. They're now being advertised towards. So now fairness has less problem with it. At least not in this end. We have as much red and blue going on. This is nice, but now we treat the two groups differently. The blue team has more blue going on. The red team doesn't. We don't like that. So we make that symmetrical as well. And there we go. According to most fairness metrics, this is a fair system. So we show the very polarized people who aren't going to change their votes no matter what. Show them advertisements for the one group. People that are very susceptible to being influenced, we show them advertisements for the other group. And so we get to shift the population quite considerably towards Team Red, while most fairness definitions don't mind this actually. They say this is a fair system. I would like to disagree. Gerrymandering in this case is for the idea of cleverly dividing and conquering, being able to move attention in one way while achieving the desired result, a manipulated election. Now, the fact that I thought this up isn't so spectacular. You can now manipulate elections, don't do that. But this actually happened in real life. Cambridge Analytica has been quite open, by now they're defunct, but about having manipulated election in quite exactly this way in the United States, United Kingdom, Philippines, and many more, doing quite exactly what I described just here, which is not entirely recognizable. So how did we get here? What's going wrong in this picture, which makes us unable to detect this? And in my book, that's the fact that we're treating the real world at the tail end of this as our actual black box. Fairness metrics typically stop at the score the model produces. The model walls are the only thing we are judging on. Well, there's more going on after that. The changes in score were amplified by the susceptibility of the population, meaning that even a small change in attention there can lead to very large changes in the real world. At least in my opinion, we should care about, if we care about fairness, about what's going on in the real world, about the actual societal impacts of the changes we make in our system, not in the changes that our system produce. So now we know how you get here. How do we get out? The first one is intuitive from the last slide, model the societal outcome, which in this case would mean actually model how much the vote would shift depending on what they are exposed to. And in that case, you would show, well, we're actually influencing the election quite a bit. FedML is also a term that's used commonly, fairness, accountability, transparency. But just those three criteria might not be enough in the way we're doing it right now, because we're looking at the model itself only and not looking outside of it to the real world. If the proposal we have is bad, the fact that we make it accountable and transparent doesn't really matter. Another thing is make explicit which harm we address. Typical French papers don't do this right now. They just kind of go for a numerical definition and say, well, we can reduce this number to 0, which is good, which might not address the actual societal harm. And one thing in general might be good if we're trying to address social outcomes, cooperate with social scholars. They specialize in this stuff. The other thing we can do to get out, regulation. Not all problems related to IR have to be solved within our IR field. We can go, we have detected a problem here. It's a problem related to IR, but frankly, we are not very good at solving this exact problem. We need a social problem, get the social people involved again. So if we ban micro-targeting, we can no longer just address those that are most susceptible. We have to address a broader population. This stops the point. But then we need some collaboration with legal scholars to ensure these steps are being made at the right time. In conclusion, fairly swiftly, information retrieval systems can be used to manipulate elections. They are not being detected by either users or the current systems. This is probably bad. Fairness metrics typically evaluate just the model, whereas there's a larger system around it, both at the start and at the end, that could also be evaluated if we're trying to do societal impact. Gerrymandering is a pretty useful metaphor for capturing this problem. And as a final point, collaborate with people from other fields. It's nice, help you get new insights. It's a good presentation. Thank you.
Team, any questions or comments?
I'm wondering if you're planning to design a number of different metrics that capture normative assumptions about what it means to actually manipulate election, because you might argue that, well, just giving people as much information as possible and giving the same information to everyone is like the way of ensuring that then election is neutral, but then you say, well, there are different, people are susceptible in different ways.
Yeah.
And there are some studies that also show that if people are exposed to information or points of view that are not aligning with their own point of view, it just gets them more angry, while some people actually appreciate that there are other aspects. So this is really hard with wondering how these kinds of things.
Yeah, so there's the point of, there's a lot of work to be done there. This is the best thing I can say right now. But the main thing is that we have to make some model of it, at least leaving it outside of the picture and going, someone else will deal with this problem. Frankly, I'm not a social scholar myself. I have a supervisor in law now, so there's why the legal part might be covered. I really need collaboration in the social part. But there indeed, I think some different models are needed. Also to capture different intuitions. I was maybe planning a show of hand on whether this would be a fair system or not. I was afraid I'd get too many hands that maybe this is a fair system. We are doing advertising, you're maybe allowed to be unfair in that. So I feel like there's no one clear solution, obviously. There will need to be very many moving parts and we'll need to get somewhere. My main approach is indeed just to get some framework like this on the road, a utility step added at the end. Probably more in the conceptual part than the IR part to start, and then start plugging actual applied AR problems where we can very narrowly address this into the framework. That's it. Please.
So how does the problem change with like different election systems? I mean, the ESSIR election system is extremely sensitive to it because you have like swing states, gerrymandering. What about countries with a more sensible election system?
Yeah, so the original study was done in India as well, or Australia, which is similar to India, which I think is not. Where the effect diminishes, we cannot no longer micro-target so much. So traditional fairness metrics are more able to counter this or to measure this at the very least. However, the general idea stands, and that we can still target those most susceptible and hiding away. Just in the Netherlands, where I'm from, since we have so many parties, you don't need to be quite so explicit in getting it that way. It just kind of goes up in the larger rate of things. So this is quite America-centric of a problem.
So this is kind of a hot topic among my group of friends and I back at home.
Yeah.
We're always debating whether the Cambridge Analytica stuff and the other examples had a strong impact on the election. I think it would have had a strong impact. And I was just wondering, like, I only had the time myself to go into that type of research to prove my friends wrong.
Yeah.
So, like, is there a research body where they actually quantify the impact that these things have on elections?
So spectacularly little, I will. There's, I was very much looking for this for concrete figures, but unsurprisingly, Cambridge Analytica hasn't been very forthcoming in sharing their data. So in that sense, it's very hard to judge. You have the general problem with, again, this being very distributed manipulation. So in order to actually judge this, there's no one easy way to find tip teams, find many different users. So really most of what I have to go on is the claims of the Cambridge Analytica press themselves, which you can probably find in some videos. We've done all this. Promise you, we've manipulated all these elections, which I think is a weird claim, but yeah, since they seem to be hired by many more people, and I guess they're onto something.
What solution you said to ban micro-targeting? I think the challenge there is like, where does micro-targeting start? Like,
Yeah.
If you put a billboard in a swing state across a highway where you know a lot of people commute, which are like, I don't know, undecided, is this already like micro-targeting or not?
Yeah. That's the problem where we go from, well, it's not just an algorithmic problem, it's a problem, well, not a problem, it's a thing in the broader world as well. If it was the Socialist Party, I wouldn't advertise at the Yacht Club. And if I was the Conservative Party, I wouldn't advertise at a gay bar. This is micro-targeting, not that micro. So I feel like the main thing that's happening here that's bad is slightly broader than I presented in here, but I had 7 minutes and 5 pages. It's also that we can really micro-target these messages. We do not have to spread the same message to one poster to each of them, but we can go, hey, you're susceptible, and you're susceptible exactly because you're scared of foreigners entering your countries. Now we're going to plaster foreigners entering your country, vote this on your wall there. That's the level of targeting I feel is really malicious in that sense, and should probably be banned. And that's something that has no direct equivalent in the real world. At least not to that extent. So the problem here is not so much we are targeting people, but the extent to which it is possible in the digital world, which sets it apart from the real world equivalent.
Any more questions? If not, let's thank Tim for the Okay, we have next speaker, Shui Wang, on improving effectiveness and security in federate online learning to rank. Find here. I'm seeing the laptop.
My mouse. Which one is it?
Shui.
What?
Oh, it's Keynote.
Keynote. All right.
Sorry. Maybe I can convert to PDF. Okay.
Oh, no, it's okay.
I just play.
Okay, that looks good.
Is it okay?
Yeah, that's
Same
good
here?
position.
Okay. Okay. Hello everyone. My name is Shui Wang. I'm a PhD student from the University of Queensland in Australia. So mainly I work with Guido Zuko, who is also from University of Queensland, and Bevan Cookman, who is from the CSIRO. It's an Australian research institution. So today I'm going to talk about my research topic. It's about improving effectiveness and security in federated online learning to rank. Okay. Okay. So some background about this topic. It's mainly about online learning to rank. So I guess you might remember like yesterday morning when Martin and Roman they introduced the counterfactual learning to rank, which use the historical users interaction data to optimize the ranking model. So online learning to rank is using the online user interaction data to regard as the relevance signal to improve the ranking model. So what happens here is so in online learning to rank, the ranker is learned from through online interventions to so the ranking system can control what to display to the user to do some debias in here and optimize the ranker using the user's online interaction. For example, the user's clicks as a relevance signal, relevance feedback to optimize the ranking model in an online manner. So it's an online training. So to give you an example here, so first of all, in online learning to rank, system, the user issues the query to the ranking system, and the ranking system will rank the document using the existing ranking model to show to the user. And in online learning to rank, it uses the online learning to rank algorithm, which is to make some modification to the displayed list. This step is called online intervention. For example, the algorithm will like move the lower ranked document to the top, which to the bias. For example, the position bias that happens in online learning to rank system. And after user saw the ranking list, user might click some they might be interested in. So for example, here user clicks the document 5. So the system will regard users' interaction, the click data to update the ranking system. So in typical online learning to rank system, the ranking model is deployed in one or several central server. So however, in this typical centralized learning paradigm, there are some privacy issue in this system. For example, here the central server needs to index the searchable data. For example, if the data to be searched contains some personal information like the email or desktop search, there be some privacy problem, like user would not like their personal data to be shared to the central server. And also the central server need to collect the user's query and interaction. So for some users, they might not their query and the interaction. For example, their click data to be searched. So to address this privacy issue, a group of methods that moves the traditional centralized learning into federated learning has been proposed, which is termed as the federated online learning to rank. So in this setting, users' query and data would still reside on their own devices, and local ranker is updated, and users queries interaction data was used to update their the local ranking model. And after the local updates finish, each client will send the ranking local updates. For example, the weight of the ranker or the gradient to the centralized server, and the centralized server will aggregate all those information from all clients, and to aggregate all information and to update the global model. And after the global model was updated, the central server will distribute it again to each client. So this is a step of global updates. And after user has more new interaction data, the federated training will happen again and again. So here you might think about why federation helps. So as we shown before, federated learning user would not like to doesn't need to share the raw training data. And another benefits of federated learning is that so imagine like if we don't do the federated learning, instead each user only has their own local data, own local ranking models. So I have an experiment here. So in the above blue line, it shows if we use the federated learning to collaboratively train the model, comparing to each client only has a local ranker, so the performance is better than the single local model. So this is a benefit of federated learning. So however, the existing method in federated online learning to rank has shown low performance, and also there's not many key elements hasn't been investigated in this task. So to improve the existing method, we propose 3 research questions. The first question is mainly about how to have improve the effectiveness of the existing federated online to rank method, which we are interested in to investigate how to design an effective and generalizable federated online to rank method that can achieve competitive performance compared to the state-of-the-art online to rank method. So because this method is like federatively trained, so we have using the centralized learning method as our goal to optimize. And the second question is about to investigate the impact of non-AI data, which we are interested to investigate our existing federated online to rank method are robust to non-ID data among clients. If not, how can this challenge to be addressed? So non-ID data among clients means the non-independent and identical data distributed among clients. So if you are thinking about practical real-life applications, this might happen. And if users data is non-ID distributed, because we are doing the federated like aggregation, so that the global model performance will be heavily impacted. And the last question is, about the secure federated online link to rank. We want to investigate our existing methods secure with respect to the potential risk brought by malicious participants. So in this research question, we are mainly because in federated learning, we don't know which clients are involved. So there might be some malicious clients involved in this scenario, which they might want to attack the model integrity. So that it's an open question to be investigated here. Yeah, so that's all. Thank you. And any question, any comments? Thank you.
Any questions?
So, I wonder, since you started off by this trying to protect privacy, if I was one of the users in the system, I was worried about my privacy. I wouldn't want my data to be investigated at all. So, like, where does the privacy come into the part where we're still searching through this data object?
So you mean which element we regard as privacy to be protected?
Yeah, which privacy are we protecting?
Here. Yeah, here as mentioned. So because online link to rank needs to index the searchable data and need users query and interaction. For example, users click feedback. So those are the privacy information we want to protect here.
Allow the service provider to create a global ranker.
Yeah.
I'm wondering, so service providers might have different goals as well. For example, computing some auxiliary statistics over user data, user behavior, discover some patterns, potentially for different forms of advertising. And I'm wondering if these parameters that we share could be used for some of the auxiliary goals.
You mean the privacy issue of sharing the parameters here, or?
I'm wondering if providers could still execute some additional statistics or additional computation, just using the aggregated parameters instead of seeing the actual user data.
Yes, yes. Using federated learning, you can only share like models parameters or only the gradient to update the model is enough. And also it really depends on like which federated aggregation or federated learning method you are using. So if you're using the most common or popular federated averaging, also need the data, the volume of data is involved.
So you talked about privacy for the user and security. What's the opposite? Like, how well is the model protected from the, I don't know, the search engine? And also, what about adversarial attacks? So when a user can detect and I don't know, wants to push certain products or results up. So what's the opposite direction in terms of protection?
Currently, just the users, as I mentioned here, the users' data we want to protect here, and also want to like we don't want to share users' raw like here raw data, raw query indexes, but we still want to use those information to update the ranker to do the online link to rank. So this is our focus here. So as I mentioned, so here's 3 research questions which focus on different like aspect of this federated online link to rank method. So any comments?
But let's say if I have my own product and then I want to boost somehow, then I can attack the system because you're using my feedback. And I could fabricate a lot of feedback and do like an adversarial attack on your system that is still not respecting the privacy, like it's still respecting the privacy of the user, but I could build a lot of user profiles and then just send a lot of like garbage information.
Yeah.
Is there any on the other side, like to respect or to control this information, to go in and you find it that this is just like fabricated data, something like that.
So I'm thinking you are mentioning like for this research question, there are some malicious clients involved in this federated training, so that the model was hurt or by the malicious clients, like the trained model doesn't work. So, yeah, so this is an interesting question we are going to investigate. Yeah.
We take last question from this.
But the last comment, a few years ago, let's say 2008, let's take it, there was a lot of work on peer-to-peer search engine information retrieval, where they were exchanging a lot of statistics between peers, and there was a kind of trade-off between centralized and decentralized, let's say. So maybe if you look at that piece of work, you can find some inspiration about all this stuff you are sending back and forth between the centralized server and the client, what they create and what not.
Mm-hmm. Yeah. So it's a comment, right?
Yeah, maybe finding out more from
Sure.
afterwards. Thank you very much.
Thank you.
Is Morris standing now, and he's giving a talk about towards the ultimate search interface, a research plan.
Das ist nicht wichtig, das heißt, ich hier auch umsetzen, wenn es geht.
Ja.
Der mit dem schlechten Titel Finance, das ist in der Mitte. Das mit dem blauen.
Ja.
Das genau. Okay, danke schön. Okay, yes, I'm also going to sit down because I got a lot of slides, so I need to do a lot of clicking. I wanted to start with a quote, which might explain my cocky title, and that is from Evan Sutherland. And he said, the ultimate display would be in the future a computer that could control the existence of matter. And for example, a chair would be generated by such a system would be good enough to sit in. And that quote was from 1965. And 3 years later, he created the first digital virtual reality headset. That brings me to my topic. Again, yes, the ultimate search interface in a reference to that quote. And I want to present my research plan with the overarching goal to explore how search could be realized in virtual reality, so an information retrieval interface. Just to really quick give you an understanding of virtual reality, this is often used the virtual continuum, where we have the actual reality, where we are hopefully sitting in right now, on the left side, and on the right side, an entirely virtual environment. And I'm only looking at virtual reality that would be quite close to a virtual environment. Yes. And virtual reality, as some of you might know, has quite a few uses already today. It's used for virtual conferences, for teaching, for remote control of machines, entertainment, of course, content creation, storytelling, journalism, simulation, marketing, and for example, data visualization, and many more things I'm just forgetting right now. But with all this data that's being used nowadays in virtual reality, the question for me at least also arises how one would search in such a system. Yeah, some more fancy examples would be a virtual museum that has experiences you could never have in actual reality, again, video games, or visiting, flying over Manhattan in Google Earth VR. So what virtual reality is actually quite good at is creating a convincing illusion of reality, like in that nice video that's showing right here, where you can go for a kayak tour. But since it's computerized and since we can program it, it's not limited to that. So we can do also things that would never be possible in reality. And that really allows us to look into new ideas for actual search. And furthermore, there are now a few other things that make it interesting to look into search. For example, you have actual natural input methods where you can use your hands, your head, every movement, all interactions basically we can use in real life are also at least theoretically possible in virtuality. You have much more space for content, at least as far as I can see, and as many objects you can render without losing performance, you can do that. Virtuality is very good for spatial data, so we need efficient retrieval then if we have such data. And it's nowadays much more widely used than, let's say, a few decades ago or years ago even. And some say it might be the final technological evolution for user interfaces. So indeed, search will be a topic sooner or later. And there's also little existing research, which makes it an interesting area to look at. It involves a lot of disciplines, so it's very multidisciplinary. Just to name a few, it would be information retrieval, what we are talking about today, but also search interface design and information seeking behavior, which goes into what the human does. We could go even further and think about cognitive psychology, which also would affect the behavior. So just to compress it a little bit, I would say all of this relates to information seeking and retrieval. That's one term. All interactive information retrieval, both of which describes thinking about search systems from a computer science perspective, but also information science, social science, psychology perspective. I did a literature review in 2021 about such systems and research that already exists. I found 16 distinct systems. I will just show you a few. For example, about query input, doing an actual search. In industry, it's still quite similar to analog search. It's having a text bar, and it's basically a 2D interface projected into virtual space. I don't really have the time, so I have to skip over those a bit, but people are doing more or less ambitious things regarding input. And most interestingly, some do, for example, 3D sketching, where you actually find an object by doing a 3D sketch and then getting the object back. Same goes for result representation. You also have like this boring lists in industry, maybe a few images on the left. People try to do that in curved displays and in existing research, or having like an endless wall. So some go beyond and have like actual 3D objects that are interconnected with a network graph. Some project onto maps. And here, interestingly, people are also looking at how to create what we know as a SERP, right? A search result page. And that might look entirely different in virtuality. Which brings me to my research plan. My research questions would be, first, how the information need that a user has can actually be communicated with such an information retrieval system in virtuality. So that boils down to having a good means of input of query, how the search results can be represented efficiently, what the general UI interaction should look like, and also how existing models of information seeking could be applied to such systems, or if we need entirely new models. One way to categorize research would be to say it's exploratory, descriptive, or explanatory. And I would claim we are right at the beginning with this. We need to do exploratory studies because there are no widely used systems. You're not all Googling in virtuality this afternoon, right? You're using your laptop still, or your phone. So I plan a bunch of studies. For example, in preliminary studies, I would do some explorative work where I might develop a few features and look how people would interact with it. And then in further studies, I would really hone in on these aspects I just mentioned. So look at the input query, later on, look at the result representation, and also see how successful this is. Are people's information needs actually satisfied with such a system? Okay, running out of time, so I will skip a bit. There are quite a few information seeking models already that are very popular and that describe either information seeking or search retrieval as a process where you start and sometime you end. They also sometimes focus on the information seeker, so the human, on the information objects of information system. So looking at those again will be a huge part of my research. And maybe in the end, in a last study, I can actually augment one of those models or even create a new model. That might be a bit ambitious, but I think we really have to look again at those models when thinking about virtual reality and search. Yes, there are a few challenges. I won't go into much detail about them right now, but I think one really need to step carefully to not just build something that's not usable and thereby evaluates very badly. Also not to spend too much time on system development. You want to consider the human in the loop from the beginning, because virtual reality is a much more immersive, human-centered computing experience compared to sitting in front of a computer. And yes, I also need to make a bunch of decisions. For example, I won't build an entire new information retrieval system. I will just assume that something like Elasticsearch or similar will be good enough. That might be an interesting discussion point here. Yes, and instead I will analyze differences in query input, result filtering, and representation or exploration. And I will see if search in virtual reality is the primary or secondary activity. So if you're doing already something else in virtual reality and then you are searching, or if you would actually be willing to put on a VR headset to use a search interface. Yes, but I will start with exploratory studies about interaction with information objects, however they might look. There's some additional considerations, but again, I will skip over them and make sure you see my reference list for a few seconds. So everybody is happy. Okay, and here I'm at my discussion. Yes.
Any questions or comments to Morris?
Yeah, thank you very much. It's very interesting. I have two comments or one comment and a question. So I remember in the 90s, people experimented with 3D interfaces.
Right.
On of course, on a 2D monitor, but so that might be interesting to look at if we can transfer it on a real 3D environment. And then we talk about virtual reality. Did you consider maybe augmented reality? Do you think there's value in that as well?
Yes. So to the first point, I actually also took a look at those 3D interfaces, and many of those studies about that came to the conclusion that they are not quite as intuitive because they're limited to our laptops, to 2D screens. And now, as you said, that might now change, right? We have a 3D, I can perceive 3D space with a VR headset. So maybe now the time has come or is coming for those interfaces. So re-examining them would be valuable. I agree. And for the second part, that's actually one of the slides I cut out of this. Yes, for now, I'm currently basically, to make it a bit easier on myself, I'm kind of limiting myself to virtual reality, because I feel like once you add augmented reality, you add even more context, because then now, why am I using augmented reality? Because the actual reality should somehow flow, come into play into whatever system I'm using. And by just shutting all that out, saying I'm in an empty room, basically in a virtual simulated empty room, I think I make it easier to really understand those first principles of search in such systems.
I would find it interesting first to understand how do we fulfill information needs in a real environment. In most cases, we use language. So I don't know if a librarian asks a question, where's the book, whatever. I think to replace data like our standard keyboard text bar, inputs like kind of boring benefit. In other cases, I don't know, we use more stuff like, I don't know, when I fix a car, I show, okay, can you bring me this piece where I show it, or show, okay, you have a similar piece, can you bring another? To understand more like humans, how do we transport also information needed in a real environment? Where do we not use language to transport each other, movement, images, whatever, gestures? then try to find like similar applications in virtual reality.
Yes, I also agree. One of the existing works I've been looking at is that people look at how we seek information in real environments, for example, at an airport, you know. And I find that interesting relating to virtuality because it's so much closer to reality. So basically, maybe some insights from even architecture, interior design can flow over into virtuality design. Yes, thanks.
Okay, so, okay, one last question, please. So we're thinking about virtual reality as an interface to search over existing data collections. And I'm wondering, what would change if you treated the virtual reality as a data source itself? So like assume that this is the world that the information is embedded in the virtual reality. Would that be a completely different set of
Good question. I'm not entirely sure, but yes, I guess the context. That's the thing I was talking about with context. Whether or not you're just using that as a new interface, like I'm sitting at my desk, I realize I have an information need. Oh, there's my VR headset. I put it on, and now I'm using it because it's useful in that way. Or I'm already doing something there, and then whatever information retrieval system works there, it can take all the context of my VR situation into account and then serve me something that satisfies my information need. So I guess that would be those two coins, sides of a coin, maybe. Yes.
Yes, thank you very much, Morris.
So so maybe I unshare my screen now.
So our next speaker is Guillemot Fdia, who is going to give a talk about modeling IR system performance towards predictive evaluation.
Can you share your screen?
Sure, I can try. Okay, so can you see it?
Yes.
Okay.
Perfect.
Hello, everyone. I'm sorry I'm online. I wasn't able to make it in Lisbon. Hopefully, you are enjoying it also for me. So my research topic involves the prediction of performance in information retrieval. And in particular, we would like to be able to achieve a system which is able to determine what will be the performance of a system before its actual deployment. As you know, evaluation in information retrieval is an highly empirical method. We have to have the collections, the data, and the relevant judgment in order to be able to assess the performance of our systems. This has some huge drawbacks, especially the cost, the time required, and also sometimes the low generalizability of findings, since they are very linked to the collection that we have attended. For example, recently we had huge problems with the COVID crisis, and we needed to retrieve information as fast as possible, and we wanted to have good quality systems that were able to perform also on this very specific domain, but we didn't know how to evaluate them since we didn't have already the collections. If we were able to predict the performance of the systems also on new collections, new domain, then we would be able to overcome the limitation linked to the current experimental paradigm and predict what happened with unseen data. So ideally, we would like to be able to use the collections rather as test beds, as training sets, in order to be able to predict what will happen in future collections and with new data. So to give you a better idea of the structure of my research, In the upper part, you can see a traditional information retrieval pipeline, actually a traditional evaluation pipeline with the user, the information need, which is used on a search engine, which is based on a given corpus. We retrieve the documents and we evaluate the performance of our systems. Ideally, my objective is to develop the bottom part of this schema with using some features, which we still have to understand which features we might use. We would like to develop a predictive framework based on some components, which is able to output a prediction of the performance. Again, this prediction of the performance, in our opinion, should follow a distributional shape rather than being a single point estimation. We will see more about that later. So the first step that I've already taken toward developing a predictive model concerns the evaluation of which features we can use in order to determine the performance of a system prior to its deployment. So we tried in this experiment in 2021 to evaluate how much different components in an experimental setup impact the final performance of a system. What we observed is an ANOVA table. You should look only at the omega square column, which indicates how much each component impact on the final performance of a system. Interestingly, we observed that not only the topic, which was already known, it has a huge impact on the overall performance of a system, but also the way in which we formulate it has a huge impact, up to 63% of the total performance. And additionally, this formulation also interacts a lot with the system itself, but also the corpus at end. We tried multiple corpora and we observed that the formulation has a huge impact when interacting with a given corpus. So we tried to go a bit further, and we also went in the direction of exploring different models in order to model the way in which we currently interpret the performance. As you certainly know, most of us to model the performance of a system use linear models, which rely on very strict assumptions, such as the normality of the data, the linearity, and the heteroscedasticity. If we consider real information retrieval data, then they are extremely different from what we would expect in the ideal scenario. So in this sense, using traditional linear models such as ANOVA or even t-tests might not be the best approach in order to be able to correctly model the performance of a system. So we aim at switching from traditional linear model to generalized linear models, which can be used to model the performance of a system according to three main elements: a distribution of the data, a nonlinear function cal-linked, which might account for the fact that this blue line is certainly not a straight line, and finally a linear predictor, which is very close to what we do already with a linear combination of the different factors in N. The advantage is that we are not more bounded by the fact that the distribution needs to be normal, or the heteroscedasticity, or the fact that the data are heteroscedastic. So finally, to go further, as I told you before, we plan to output a measure of expected performance of a system, which in our opinion should not be a single point estimation, since such a way of describing the performance of a system is not really getting describing correctly the reality. In fact, different users might interpret differently the quality of the very same system, and in general we cannot expect the users to be satisfied the same way or perceive the relevance of a document as all in the same way. So our proposal, which is already under development, aims at determining how we can represent the performance of a system in a more distributional shape. So one possible solution would be ask human, but this is very costly, or user simulations. The problem is that simulations need, first of all, we have to find a way to simulate such distributions, and also we have to understand how to adapt classical statistical inference also to make inference using such simulations. Finally, the last aspect that I plan to investigate in the future concerns causal inference. Most of the evaluation in information retrieval currently is based on correlation, which, as we know, is not causation. So hopefully causal inference might be a good framework where to start to understand what is the causal relations between the different elements that compose systems and the performance they are able to achieve. The main advantage when we come to causal inference concerns the fact that we often rely on experimental data in information retrieval. We are able to carry out our experiments, while causal inference is mostly meant to deal with observational data, which is not the typical scenario in information retrieval. So to conclude, causal inference, to conclude, the evaluation in information retrieval is mostly an empirical discipline, and if we were able to predict the performance of a model prior to its deployment, that would be really useful, both from the speed of development of new systems, but also in terms of economical costs of evaluating them. And in my research line, I plan to investigate some elements such as causal inference, generalized linear models, and distributional prediction of the performance to achieve it. Thank you very much for listening, and I'm very open to any kind of suggestion that you can provide.
Thank you. Any questions? You have done a very comprehensive talk. We don't have many questions right now, so perhaps I will ask you a question. Can you hear me at all? Okay, can you hear me?
So, very poorly, sorry. Can you hear me?
Can you hear us?
Oh, yeah, now yes.
Oh, okay. Sorry, I better come closer. Yeah, I have a quick question about this prediction model. So at the moment, which stage is it you are working on it?
So currently we have already started investigating the understanding which features might be relevant in order to determine the performance of a system. So we experimented with multiple different systems and different formulations of the topic, different corpora and so on. And we determined what is the impact of each of them in the overall performance of a system. And we already also played a bit with generalized linear models. We have our work already under revision process. So currently we are not sure whether it has been already accepted by the community, but certainly the results were interesting and also very promising. So both the features and the generalized linear models aspect have been already a bit investigated, at least, while we are still a bit back from what concerns the causal inference and in general understanding what is the causal relation between the performance and the different components of a system and the distributional predictions of performance.
Okay. So what is the next steps you're going to work on?
Or probably we are going to investigate a bit better the effect of the distributional performance and understanding how we can represent the performance of a system over a spectrum rather than single point estimations.
Okay, the line is, yeah. Okay, right. Thanks very much. Perhaps we thank the speaker again and we move on to our next. Is Gabriel in the room? Hi, Gabriel. Gabriel is going to give a talk on the text, the information retrieval in Phantom.
That's my mouse pointer there. I think it's that one, yeah. I need to share my screen again. Right.
Okay, thank you.
Good afternoon, everyone. I am Gabriel De Jesus. I'm going to talk about text information retrieval in Tetun. Basically, it is a research plan. I will start by introducing Tetun and motivation behind the research, the objective, and then the problem to be tackled, the research question, the methodology to be used, and conclude with the conclusion and future work. Tetun is one of the Timor-Leste official languages alongside Portuguese, as we can see here. Lorokraitia is Tetun, which means good afternoon, and boa tarde in Portuguese. Based on the Census 2015 report, there were 1.17 million of the Timor-Leste population, where 79.04 are Tetun speakers, which equivalent to 932,433. Based on the literature, 32 to 35% of the verb, nouns, and adjective are Portuguese loanwords. As we can see here, agradecer is a verb, apresentação is a noun, and importante is an adjective, which are basically Portuguese loanwords. The motivation behind this research is that the IR techniques and algorithms for Tetun do not exist as of now, and as well as the corpus for IR task. As we can see in the picture, if we enter the sentence into the Google search engine, it interprets several some words in different languages. As you can see in note 1, opinion was interpreted to opinion, which is English, and funcionario was interpreted to funcionario, which is basically Portuguese. Therefore, in this evidence motivated us to initiate developing the IR-based approach for Tetun. Moreover, Timor-Leste is a multilingual country. We have 2 official languages, Portuguese, Tetun and Portuguese, 2 working languages, English and Indonesian, and we have more than 35 local languages or dialects. In addition to that, we have 2 different standards for Tetun, which is one standard developed by the government, we call it Tetun INR, and the other developed by Australian linguists from the one of the university in Timor-Leste. Moreover, we have also one dialect which is Tetum Tere, which is another version of Tetum. Therefore, we have a wide variation of Tetum when it comes to writing. Since IR-based approach for Tetum do not exist, finding documents in Tetum becomes a major issue. To respond to this problem, we intend to develop solutions for search in Tetum, including a search corpus, a Tetum corpus, the specific IR algorithm and techniques, as well as a test collection for the evaluation. Therefore, we have three main questions. The first is we want to investigate what text preprocessing techniques can influence the text retrieval result in Tetum. Considering that we are going to develop specific algorithms for and techniques for Tetum, this research question broadens our knowledge to select or to investigate which of the preprocessing technique that can contribute to the search result. And the next is what indexing and retrieval strategies provide the most effective solution for Tetum text search. We have already initiated one preliminary result, but it is not presented here, but you can find in the paper. We have identified some techniques, but we will do more investigation to make sure to identify which strategies that work better, provide better solution for our search problem. And the last one is what query processing techniques improve the quality of the documents retrieved. As I have explained that we have a mixed bunch of writing when we come to the writing. So we want to investigate which techniques from the query processing side that can help to provide to improve the documents retrieved. To do so, since it is an ongoing research investigation, we will study the existing literature specifically for low research language, whether it is traditional approach or IR-based approach, that we can to identify which approach that can help to support our study. After that, based on the Google indicator, there are around 0.48 million documents from the site hosted under the top-level domain of Timor-Leste.tl. We will develop a crawling to collect the documents to build the corpus for Tetum, as already explained in the objective. After that, we will develop some specific techniques and algorithms for Tetum, and then a prototype to build the test collection. So we will involve the Timorese expertise from different background to do the judgment of the relevance of paired documents and query. After that, we will evaluate our solution, the effectiveness of the search, whether it is using the traditional or modern or neural-based approach. And then after identify the best search solution, the most effective one, we will implement in the Timor News, which is an online news agency, news platform, to do the further evaluation using A/B testing. To conclude, we are presenting here our research plan for the next 3 years focus on the ad hoc retrieval task. We have, as I already explained, that we have initiated a preliminary ad hoc experiment, but considering the time constraints, we couldn't present here. In future, we will follow the methodology that have shown in slide 8. Thank you.
Questions or comments to Gabriel?
Do you think there's some grammatical or other linguistic features of the tool that might make retrieval more or less difficult than in English or in Portuguese?
Do you mean dictionary portetum or
Maybe declension rules or the ways the words are formed, any grammatical or linguistic features?
portetum? We basically, as I have explained, that we have 2 standards. One is the standard established by the government, the other is by the academia team. So we have a dictionary basically, and it is also, we have electronic one, but very limited version. So what will happen is that, of course, if we comes to use the dictionary or lexical base, it will be the out of vocabulary issue will happen. So we will try to find out which is the best approach that we can be done. As we can see that there are several works for low resource language. I think the most well-known, the recent research is maybe transfer learning, this kind of work. But our concern is that we don't have a test collection for the evaluation. So I think to develop the specific algorithms, to develop the corpus, the first objective is to build a test collection. Then we will try with the different approaches available in the literature. Then we can evaluate which one is work better with to resolve our solution, our problem.
Yes, Morris.
Yes, I guess the day up until now was quite interesting for you, since we heard something about new approaches, but also have like a parent and then child model that mimics the parent model. And I guess depending, and also related to the previous question, how similar Tetun is, for example, to Portuguese, maybe that would even work, right? To mimic the Portuguese model and then have it adapt. My question would be, do you have access to native speakers of Tetun to validate whatever you add up to the corpus or model?
Yes. So basically, based on our preliminary experience, we develop a guideline for the evaluators. So basically, it was evaluated by five evaluators. So how to so it is basically we run using Solar platform to for 5 queries for using the around 450 documents. Then we provide the pair of the query and the documents. Then it was evaluated by the several evaluators, or just by them. Then we come after that, we do the majority voting, and then we come to the we have the test collection, which is in very limited version. Then we evaluate the effectiveness using precision at 5, 10, mark, and also NDGC. So this is we already have insight how to do the how to build the test collection. So the next step is that how we can collect or build the corpus with big amount as well as a query, so that we can build a standard, a better test collection that can be reliable for the next experiment to like to develop the solution for our search problem.
We don't have time for more questions, so let's thank Gabriel again for the interesting. Our last speaker to talk about a multitask approach to explaining clarification questions for task-oriented conversational systems.
Which one is yours here?
That one. The systems.
This one.
Yeah, that one. Yes.
All right.
Thank you. Hi, I'm Jerome, and I'll be presenting my work on multitask approach for explaining clarification questions in task-oriented conversational systems. So as an introduction, as you know, there's been a lot of research on chatbots in a number of domains like e-commerce, music recommendation, and general chit chat. So you can imagine things like Siri and Alexa. There's been a lot of focus on improving the models. However, because many of them are deep learning-based approaches, they are black box models and they're hard to explain to users. So the goal is for explainable AI to increase the user confidence and to help users make better decisions and faster and increase the ease of use of the system. So I guess as a related work in general for AI, there's been two different branches of explainable AI. So there's the inherently explainable model where the explanations can be generated during training. So there's a set-based approach and additive models as examples. And there's also post hoc explanation modules. So an example would be model agnostic methods like SHAP and LIME and counterfactual learning. And these methods happen post-training. So as an example, here we have SHAP values on the right, and this can be helpful for doctors because they see, for example, that age is a very important feature in this mortality model. So moving on to conversational systems in particular. So we worked with the SHARC dataset, which is a conversational machine reading task, which is a type of task-oriented dialogue system. So given a rule text and a user scenario, the bot must answer a user's question or answer an additional follow-up question. So in this example, at the top text, we have the rule text, and this is the sort of rules that are explained in a natural language text. And then some of the rules are implicitly written inside the user scenario. So a user might say they served in the army and they were never in active duty and so on. And then the bot also has a explicitly written dialogue in the dialogue history. So this is previous turns with the user. So for example, the bot asks the user if they are a veteran and they said yes. So the end goal for the bot is to either say yes or no to the user's original question. Does this program meet my needs? Or say that their question is irrelevant and cannot be answered to the rule text. And finally, they can also generate an additional follow-up question. And this happens if not all of the rules have been covered so that the bot can return a final answer. So here we have an example of one of the current state-of-the-art methods. This is the discern paper. So they highlight underspecified spans, which is mostly used for question generation, but these spans would not be a sufficient answer alone to explain. So for example, if it said, are you able to get financing from other resources? And the user says no, the bot just says yes, but the user doesn't know why. And this might be, in this case, trivial because all the answers are yes. But for example, if the user said yes as the follow-up answer for answer 2, the final answer would be no, and they'd want to know why the answer was no. So returning, if you only return the bold text, which is the underspecified rule, it wouldn't be enough. So we want to extract all of the relevant parts of the rule text such that the user could understand what the explanation for the answer is. So an ideal explanation is highlighted in blue. So the model outputted, do you have a disability? And the user might ask, why do you want to know if I have a disability? And they could say, the bot would say, public housing provides affordable rental houses or apartments for people with disabilities. And as you can see, this is highlighted inside the rule text. So in order to gather those highlighted rule text, we developed a crowdsourcing application in Flask and JavaScript. And we sourced workers on Amazon Mechanical Turk to highlight parts of the rule text that could explain each follow-up question in the data set. And users were encouraged to highlight complete sentences, as these are more simple explanations for users to understand once it gets returned. So all of the highlighting was done for conversations in the publicly available Shark dataset, which is about 24,000 examples. There's also a private test data set, which is used for the leaderboard performance, which I didn't have access to. So it's only for the publicly available training and test and dev set. So here we have a multitask model. So what I did was I tokenized the rule text question scenario and all of the follow-up questions using Roberta. And there are two tasks to be trained. So one is the original Shark data task of classifying the answer as yes, no, more, or inquire. And it's a simple feed-forward network. And then the second task is a multi-span explanation tagging, which I'll describe in a bit. So previous papers rely on single span highlighting because they are under specified spans, but explanations I saw in the previous example tend to be multi-span, so this technique wouldn't work. Therefore, we decided to treat the multi-span highlighting as an IO tagging problem, which is a common problem in named entity recognition. So each token in the rule text, once it's encoded using Roberta, is either inside or outside the answer. So we train the model to choose, classify each token as either I or O, and we train to minimize binary cross entropy and take the tag with the highest probability at test time. And then here's a gloss over this, but it's the question generation task. And this is generally trained separately from the decision classification task in previous models, because they found that training question generation and decision classification at the same time tended to worsen performance. Therefore, a second model was used. And this is similar to previous state-of-the-art models. So I'll just pass over that as there's no explanation parts there. So for the decision classification task, it compares fairly close to it. It's not quite at the same level as DGM, which is the current highest accurate task model in the Shark dataset. But as you can see, it's a relatively good performance. So if this were to be deployed in the real world, developers would have to weigh the trade-offs between accuracy and explainability. But overall, the overall accuracy isn't too hard from our model compared to DGM, especially given that the decision classification for our model is a simple feed-forward network, unlike some of the other state-of-the-art models which use more advanced techniques. So in the explanation task, we used EM and F1 to calculate the IO tagging task. So we could see those two benchmarks as well as a user score, which is manually asking annotators if they think that the explanation return makes sense or not for that given conversation. And then we omit F1 for irrelevant because there's no I tags to be tagged in ground truth. So it would default to 0. But a better case in irrelevant would be the exact match because it's either blank or it's not because there's no explanation for an irrelevant conversation. So overall, the metrics seem good, but a big problem with the metric is that F1 and EM don't really capture if the explanation is syntactically correct. So for example, if a couple of tokens were mistagged, it can lead to answer that's a bit nonsensical in English because it's adding extra words or removing words that doesn't make sense, but it would still have a high F1 score because most of the tags were properly classified. So for conclusion and future work, so they perform reasonably well. So as I said before, a developer would in the real world would need to weigh the trade-offs between a couple more points in accuracy or a little less accuracy, but an explainable model. So there should be better metrics to compute performance of the extracted explanations, because as I said, EM and F1 aren't totally the best because they don't capture the meaning of the explanation. And of course, asking users to annotate if explanations are good or not is not scalable. So the quality of the explanation is also highly dependent on the structure of the rule text. So if the rule text isn't worded in a way that's easily highlightable for an explanation, it could not lead to a good explanation no matter what someone does. So a generative approach might yield better results. So rather than highlighting, we have a natural language processing model to generate explanations. And then another interesting future thing I may work on is, can we apply it to recommendation domain? So an explainable conversational recommender system. So yeah, that's it, and open to any questions.
Thank you very much. Time for one quick question. Yes, please.
In your Amazon Mechanical Turk experiment, how do you validate that Turkers are doing what they are supposed to do? Do you have control questions? How do you do it?
So I ran a couple. I ran, I guess, a small set of 100 Mechanical Turk just to see if their answers matched up close to each other for quality control. And I did see that the Turkers were doing what they were doing. So afterwards, I released a bigger set of mechanical work data set task for the whole data set. And then once that was complete, I ran a validation task for a separate group of crowd workers to validate whether or not the answers were good or not. So any answers that were not good were flagged and then sent for re-annotation.
Another quick question at all? We've got 1 minute. Yes, please.
So it's a matter of means people have shown that when you provide users with explainability techniques, sometimes they end up trusting the system more than they probably should. So I'm wondering if you think that in the case of conversational systems that can lead to problems as well.
Yeah, I think it's definitely possible and a good avenue to look in. And I know one interesting topic for me is also scrutability. So they could see, since they have the explanation, whether or not they agree. So for example, if the bot returns something and they think their user scenario doesn't fit it, they should be able to tell the bot that that explanation is wrong and fix it. But yes, I think that the trust is definitely an issue worth looking into.
Thank you. I suggest we take the discussion offline and to the break time. And we're having our well-deserved break. I'm very sorry for running late. So now it's 3:50. May we suggest we have a 10 minutes break and come back at 4 o'clock? Like we have 10 minutes break instead of 20. So then we can sort of finish on time or not too late for your banquet. Please. Thank you very much again to our last speaker, by the way.
I have wrong in the date.
Sorry?
Wrong in the presentation date.
I would suggest for us to leave picture. Yeah.
Gabriel.
Sorry?
I have, the date in the presentation is instead of 2022, 2020. Yeah, I mean, if it is
only those who pay attention that were
Yeah, but if it is not included in the ESSIR side, Fdia side, then no problem.
No. It's so what we will do, but I think I will announce that it's all recorded. So if you don't agree that it's later visible on YouTube, then you should tell us. Oh yes, I think I have. Yes. Let me see. Which ones are they? Could you
Yes, fluffy. Yeah.
This
Thank
one.
you very
Yeah,
much.
okay. Okay, cool.
I don't know if it is necessary, but I send the slide from the lighting to.
Yes. I think I have that here. Is that Antonio, right?
Okay.
Yeah. Perfect.
Yeah, you're going so quickly because when I can bring your coffee.
So Ornella, are you here?
Yes.
Right.
Still wait
I
a
sent
minute.
you.
Yes, yeah. Should have it. Which one is yours? What was the file name again?
Fdia underscore Herrera. It is a point pptx.
Do I have it here?
Maybe you don't have. Well, I sent you
Yeah.
the email, but
I'll just check.
and this is Fdia.
Oh yeah, there.
Okay.
Yeah, of course. I need my glasses. Okay, so yeah, welcome back everybody, and whoever is still in the coffee break, they don't know what they are missing, but okay, that's it's their loss, not ours. Okay. So yeah, next speaker is Ornella Herrera talking about data search.
Thank you. Good morning, everyone. I'm Ornella Herrera, and I'm a first-year PhD student at the University of Padua. And today I present you my research project, which is data search in practice, how to find scientific data sets and to link them to the literature. Well, okay. Well, I collaborate with the ISTI, CNR of Pisa, in Open Air European project, which provides a set of infrastructures whose purpose is to facilitate scholarly communication in Europe and promoting open science principles and goals. One of the infrastructures provided by OpenAIRE is the OpenAIRE Research Graph, which is a graph database where the metadata describing research products such as publication, research dataset, and software are semantically interlinked. There are some disadvantages related to this implementation because metadata describing research data and software are not usually complete, and they cannot represent the research outcome at best. This incompleteness causes difficulties in reusability of the research outcome, its discoverability, and difficulties in credit attribution mechanism. Moreover, the lack of complete metadata prevent research dataset and software to be connected in the graph. So there are a lot of isolated nodes, and this is what prevents discoverability and credit attribution mechanisms involving authors. In my project, we plan to design a system that relies on the combination of data search, data connection, and data enrichment strategies to find a set of research data set which can be connected to one or more publications and enrich their metadata and provide a semantics between the dataset and the publication. To do this, we define 4 different research scenarios. Each one is characterized by a subgraph extracted from the OpenAIRE Research Graph according to 2 criteria. The first one is the quality of metadata describing research data. And the second one is the presence of connection or absence of them between literature, which are publication notes, and research data. Each subgraph is of different dimensions, quality,
and is characterized by different complexities. And each subgraph allows us to define data search, data connection, data enrichment strategies separately. With this approach, why are these scenarios so important? Well, first of all, they facilitate the development of the strategies we propose. In fact, they limit the size of the graph we work on. But with this approach, we can understand how research data are used inside the graph and how they are cited. And in particular, in 4 different contexts belonging to the same graph. And we can also understand if the technique we propose and we study in 4 different scenarios are generalizable to the entire graph we work with. The first scenario we propose is described by detailed metadata, so metadata with high quality, and publications are connected to a research data set. This is the ideal scenario because it is the best situation we can find inside the OpenAI research graph. And we rely on these features to create a curated ground truth we will use in the next scenarios with evaluation purposes. We first extracted the European marine science community, and we filtered the nodes according to the requirements we imposed. And then we created this community in order to disambiguate author and validate metadata and enrich them. The requirements about connections is what affect the final size the most, because the initial community contained more than 100,000 nodes, research data nodes, and after creation, we had about 5,000 nodes, and this is mostly related to the presence of the connections. In the second scenario, instead, we have poor quality metadata, and we require the connection between research data and publications. We rely on the connection to enrich nodes metadata. In particular, for what concern publication nodes, we rely on the text of publication to extract information such as the title, the abstract, the authors, the keywords extracted from the keyword section, but also relying on entity linking systems in order to extract a set of informative words about the topic the publication is about. For what concerns research data set instead, we can rely both on the textual publication, because sometimes there are some dedicated sections in the publication which contain relevant information about the dataset they used. And we rely also on the dataset itself to extract some information such as fields, attributes, or measures. And we obtain a graph which have the nodes enriched with information extracted from different sources. In the third scenario, instead, we have good quality metadata, but we don't have any connection. In this case, we can rely on good quality metadata to extract a set of research data set which can be probably connected to one publication. Then we can predict the presence and the type of semantics which link the research dataset we extracted relying on data search technique to the publication examined. This is the last scenario we proposed. In particular, this is the worst scenario we can have, but it is also the real one because the largest part of nodes belong to this scenario. And so we have poor quality metadata, and we do not have connections. In this case, we have our final system where all the techniques we proposed are integrated, are combined together. to iteratively search for a set of data sets, enrich them and connect them, deciding the correct semantics or the most probable one. And it is in this scenario that we can understand what the limitations of our technique are and what the points of strength are, and we can understand if the technique we proposed can be generalized to the final graph. Well, with this project, we plan to give a valuable contribution to open science domain, and in particular to the OpenAIRE project where I collaborate with. But I think that this gives us important information on the conception about research data in the research life cycles, and in particular how it is used, how data set are used in OpenAIRE research graph, which are the data I rely on in this in my experiments. And our final goal is to effectively integrate the technique I proposed and check if they are actually generalizable. So I'm open at your suggestions and comments. Thank you.
Any questions?
So it's really interesting you're actually focusing on the use cases and domains. I'm interested to know, as you are in your first year, have you developed your research questions yet based on this work, or?
Well, actually, we are releasing the ground truth based on European marine science domain. So I actually finished my first scenario. And so the next 2 years, I will focus on the second one, the third one, and then we can see if the three techniques combined can give valuable results. Okay. Thank you.
Yeah. Which data sets of architect data are you using to produce the kind of it sounded like you were kind of like merging data sets together, finding
all the data sets belong to OpenAIRE research graph. They are all provided by OpenAIRE. They aggregate metadata about research data sets from different sources, and they aggregate together in the graph. So they are all provided.
I'm aware of this data set from Semantic Scholar. It's like, I'm just curious if that's included in the OpenAIRE, because for my own usage, I might focus on the OpenAIRE data set. Is that included in the Semantic Scholar?
Pardon?
Oh, sorry. So there's a big data set from Semantic Scholar. I'm just curious whether that's included in the OpenAIRE data set. Is it like, is it a subset of the OpenAIRE data set?
Well, I think that there are some publications within Semantic Scholar I included also in the OpenAIRE research graph. But there are a lot of dumps online about research OpenAIRE, so it is all it is open access, so you can check.
At least on the code part of this graph, it seems that Papers with Code has discovered for these parts that you integrate with or familiar with.
With the code, with the open source code.
Yeah, so Papers with Code is an initiative going around to sort of do this. Then from author side, they can present their code attached to it, make it runnable.
From a graph perspective.
Like if you're integrating with this at all, if you're familiar with it.
No, at the moment, no, but maybe in the future.
Yeah.
It is interesting. Thank you.
Okay, I suggest that we stop now. Yeah, and there's a whole banquet where we can discuss further issues. And, so thank you very much again.
Thank you.
So our next talk will be online. Let's see if this one. See if we can get it running somehow. Maybe I unshare first. So Tendai, are you there? Huh?
Yeah, I'm there.
Fantastic. Can you share your screen, please?
Sure. Okay, let me.
So while we wait, we are recording all the talks on YouTube. If any of the speakers has any objections against that, then please let us know. Then we will see if we cut the presentation out or whatever we do then. Huh? Tenda, are you working on sharing? Yes, the right permission is right. Is everything okay, or we have a serious
Okay.
problem?
Just some challenges with my other device. Can you let me in with the second one?
Okay, Bruno, please.
This meeting is being recorded.
Thank you. Yeah.
Okay.
Or just Tenda can email us his slides.
Right as well, yeah.
I'm not sure if the microphone is off. Absolutely.
Okay. Tenda, do you have a problem with sharing? Because otherwise you might email us your slides and we can share them here. Apparently your microphone is off, the other one. Oh. Bad. Who's next? Screen. Schon mal use this one.
to share again.
Okay, we continue for the time being with the next presentation, and if Tenda returns and sorts out the problem, we will squeeze him in. Okay, yeah, thank you. Stage is yours.
Hello everyone, I'm Bing Liu from the University of Queensland in Australia. Today I'm going to share my PhD research topic towards practical knowledge graph alignment. So first, what is knowledge graph? Knowledge graph represents the knowledge in the form of a graph. In a graph, the nodes represent the entities. For example, in this figure, there are some entities: New York City, Donald Trump, U.S. Republican Party. Also, the literals are also thought as a special type of entities. In the graph, the edges represent the relationships between the different entities. For example, Donald Trump was born in the New York City. He is a member of the Republican Party. There has had already some applications of the knowledge graph in the IR. One typical example is Google search engine. You know, if you search the Donald Trump in Google, it not only shows you the document entries, but also on the right side of the website, there will be an info box. This shows you some very brief knowledge about Donald Trump. So those knowledge are semi-structured or structured. Since the knowledge has been stored in a structured form in the knowledge graph, it can support the search engine to return the answer directly. For example, if you search the born city of the Donald Trump, and on top of the research results, it will tell you it's the New York City instead of just return a list of documents. So even though there has been some large-scale knowledge graphs, one critical problem of the existing knowledge graph is the incompleteness problem. The reason might be the knowledge source might be very limited, or the knowledge extraction techniques might be not good enough. But also we notice that different knowledge graphs might be complementary. They have some overlapping knowledge, but at the same time, they have some different knowledges. So if we can merge those different knowledge graphs together, we have the chance to get one more complete one. Anti-alignment is a primary step for merging the different knowledge graphs. It aims to identify the equivalent entities in the different knowledge graphs. For example, now we have one toy knowledge graph about some political knowledge. Also, we have another knowledge graph which contains some business knowledge. So we know in the two graphs, the US on the right, on the left side, corresponds to the America on the right side. Also, the Donald Trump on the left side corresponds to the DJ Trump on the right side. So the challenge of doing the entity alignment is the same entity might be expressed in very different way in different knowledge graphs. For example, there are some knowledge graphs that's in different languages. But you know, even in the figure, they are both in English, but in terms of the name expression, there are some different variations. So typically we need to exploit the structure information so that we can find the evidence to match the different entities. Next, I'll give a brief introduction about the neural model for the anti-alignment. The neural model are currently the mainstream methods for the anti-alignment. So basically, we have two knowledge graphs to align. Usually, we also need to pre-align some mappings, which is used to find more unknown mappings. So the new models are needed, and they are having a lot of works that propose different types of neural models. Those models typically encode the entities into the embedding representations, and then it matches the different entities in the embedding space. For example, by doing the similarity computation. Before we use the new model, we need to train it in a training framework, like in the supervised training or semi-supervised training. Afterwards, with the well-trained new model, we can predict more mappings. But the existing neural models are like the toys. When we try to deploy them in the applications, we find that there are a series of problems, like the annotation cost, and they typically has a very poor scalability, and also their effectiveness are very limited. So in my research, I try to solve those limitations so that we can go towards the practical anti-alignment. So the next, I introduce the four research questions. So the first one is about how to apply the active learning to address the annotation cost problem. We know in the supervised training, we already get some annotated data, and then we design the model to do the training and the other things. But the active learning, it does not work in this way. It does not annotate many data in the beginning, and instead, it may use some sampling strategy to sample a small number of data and send it to the annotator. After we get some new level data, we use it to update the model. Afterwards, we enter the next iteration. In the next iteration, we select the data to annotate based on the performance of the current model. We select the most informative one to annotate. So the process will continue until the budget of the annotation run out. In the scenario of the annotated alignment, I investigate how some special challenges, like how to combine the model uncertainty with the graph structure, also how to avoid selecting the unmatchable entities. Those entities are actually useless in the training. To address the limitation in terms of the effectiveness, I investigate another two research questions. The research question 2 is how to guide the training process with the compatibility. And the research question 3 is about a more effective semi-supervised learning framework for the anti-alignment. So for the research question 2, the compatibility is the core concept. So what is the compatibility? I give a very simple example. For example, in the source knowledge graph, we have one triple, like its father is B. In the target knowledge graph, we have another triple, like A prime's mother is B prime. So if one model predicts A is equivalent to A prime, B is equivalent to B prime. You will think it's a ridiculous prediction, since someone's father and mother cannot be the same person. So even though we don't know what's the ground truth, but we know it's impossible for those two mappings to coexist at the same time. So we claim that making compatible prediction should be one objective, apart from fitting the training data. In our third research question, we proposed one semi-supervised framework for the anti-alignment. The working process of the semi-supervised learning is we already have some label data, and then we use it to train the model. Afterwards, we use the model to make prediction, and we designed one strategy to select some pseudo mappings which are we think they might be correct, and we add them to the training data, and afterwards we retrain or continue training the model. So this process will repeat until the convergence. There actually has already some semi-supervised training framework, but we found they usually generate some noise. So we propose more better strategy that generates less noise. The last research question we investigate is about the scalability. We know when the knowledge graph is of large scale, in practice, the knowledge graph usually has millions of entities. But the new model usually run in the GPU. GPU memory is usually very limited, and you can hardly fit one large-scale knowledge graph into the GPU. So now our idea is to divide the big tasks into the small ones. So specifically, it will be divided both knowledge graph into some small knowledge graph pairs. There are some special changes here. The first one is how to protein the coverage of the potential mappings, because after you do the dividing, some potential mapping might not be able to be covered by any subtask. Another challenge is how to keep the sufficient evidence for the entity matching, because since the graph structure has already been broken, and also there are some pre-aligned mappings, they may also disappear in the process of the dividing. So how to keep as much evidence as possible is one problem. All right, those are the 4 research questions in my PhD topic. Thanks for listening.
Questions? I'm very interested in your research question 1, with using active learning. So do you use, what do you use to train the data then? Do you use real users, or is a reliable training model you can actually actively train the data?
Sorry, can you repeat the question?
Okay, so for your research question 1, you're trying to use active learning to train the model. Instead of pre-train them, you want to train them during the process. And who is training the data? Are you using some reliable, like you call it, experts there to train the data? What is it?
Actually, the process is we still need to annotate the data, but it's not to say we randomly sample some data and then give them to the expert to annotate. Instead, we want to sample a small number of data and train the model. And then we evaluate the performance of the model. We want to select another batch of data which can benefit the current model for the most. So that we try to, in this process, the expert is still needed to annotate, but we may only need to annotate a small number which can achieve the performance that you randomly select, but the number is a lot.
Yeah, who are the experts?
They are just the annotator. I assume they can give the that can label correctly. Yeah, they're just the annotators.
Okay, so you hire them or?
Yeah.
Okay, thanks.
Thank you. Any other question?
So, thank you for the presentation. That was very interesting. And I was wondering, with this neural entity linking that you're doing, are you training on a specific domain, or are you doing a general domain thing?
Now I do all the experiments on the general domain.
Yeah. So, are you planning on doing something that can work on different specific domain, or do you think we stick to general domain?
Yeah, I think I'm pretty interested in applying my method in some specific domains. Currently, the data used are actually they are sampled from the large scale knowledge graph like Wikipedia, Wikidata, or DBpedia, this kind of large scale knowledge graph. They are actually not the actual the real knowledge graph. They are the sampled ones. So if there are some actual, real knowledge graph, I think it would be very good for me to evaluate the effectiveness of my method.
Thank you.
So maybe a naive question, but I feel like in entities typically have a name natural language that would already align.
Yeah.
Does this not work? Like just giving the natural language representation of all these entities and comparing those?
Yeah. So you mean we only use the name to match the different entities? So I think there are two problems here. And one problem is one entity's name can be expressed in different ways, for example, in different language, or even in the example I give now, for example, one English name might have different variations. Also, another problem is different people might have the same name. So, in this case, you need to disambiguate it with more information. Thanks.
Thank you. Another quick one. Otherwise, I have a quick one. So, many moons ago, before knowledge graphs, there were ontologies.
Yes.
There was also this problem of ontology alignment. Is there anything you can learn from that? I mean, it's a similar problem, but from what people did 15 years ago when they worked on ontologies and tried to.
Yeah, I think this is a very good question, because I noticed that another branch line of research is, they might design some reasoning-based method to align the different ontologies. Ontology. The previous ontology are made about the concept, but nowadays the knowledge graph are more about the instances. Now people use the neural models and almost forget the reasoning-based models methods. Actually, in my work, I try to combine the reasoning-based method with the neural model, and find it's very effective. It's kind of, when here in this work. In the compatibility work, I use the reasoning-based method to measure the compatibility, and it's. I think their combination is very good.
Okay.
Yeah.
All right. So then thank you again.
Thanks.
Kendall just told me that his problems are resolved. So let's give it another try online. So I stop sharing. Tenda, can you hear me? Yeah. That looks good. Oh, wow.
Yeah, can you hear me?
Yes, we can hear you loud and clear.
Okay, so let me share my screen.
Please.
Okay. Yeah, you can clearly see my screen, right?
Yes. Go ahead, please.
Good afternoon, and welcome to my presentation on graph representation learning for cross-domain recommendation. Apologies for the earlier network interruption. I'm Tendai Mukande from the School of Computing, Dublin City University. I'm also with ML Labs, that's the Center for Research Training in Machine Learning. So my presentation outline is I'll briefly give an overview of my research topic, the motivation, and then outline the main research questions. And I'll just give like the proposed framework overview, which is still in the very early stages. So an overview, the recommender systems, they have been they are now indispensable in decision making, and they have been very helpful in alleviating the information overload by giving preferable content products, say in e-commerce, entertainment. We have movie recommendations, professional, we have the likes of LinkedIn, we get recommendations, social platforms, we do get friend recommendations, etc. For instance, the likes of Facebook and the other social networks there. So the main motivation is to address the challenges. Currently, what we have in the state of the art is the real world scenarios are usually heterogeneous in the sense that they span multiple domains, wherever most of the models which we have, they mainly focus on a single domain. For instance, if it's the social network, say Facebook, it's just a friend recommendation. If it's a movie recommendation, it's recommending movies. But like the main real world scenarios, for instance, in e-commerce, for example, the state-of-the-art models, they will recommend products in one domain, say if it's electronics, if it's cosmetics, if it's clothing. The main motivation is to move to the real world scenario, because in the main real world scenario, we do have the user item interactions spanning multiple domains. For instance, from one user, that is one customer, from the clothing domain, they will go to electronics, they will go to fashion, they will go to cosmetics. Whereas most of the state-of-the-art models, if the data set is on electronic products, you mainly find the recommendations there. If it's in cosmetics, the recommendations are there. So the first challenge is to address the effective information representation that is spanning multiple domains, then also preservation of the model structure and semantics at lower cost, computational costs, because when we do have all these heterogeneous data, different activities, etc., is shown on the right there, we have different items, different interactions, the metadata there, we tend to have a very complicated model to try to process such data. So that's the second challenge to be addressed. Then, of course, when we do have these recommendations with this abundant data, still we do have instances where we have data sparsity issues, whereby the data, there's some scenarios do not have sufficient data for recommendation. So these are the main challenges to be addressed. Then the main research questions are how do we effectively represent the heterogeneous data into a lower dimension embedding space? That is by without losing the semantic and the structural information from the actual scenario. For instance, all those different semantics, products, purchase, view, collect, add to cart, and all the different products. How do we represent that into a lower dimensional embedding space to facilitate the implementation of the downstream tasks such as link prediction and the personalized recommendation. Then the second one is to reduce the model computational costs. How do we have an efficient model, but which also works at in real world scenarios, spanning heterogeneous multiple domains. And then the last part is to explore the proposed model performance against the state-of-the-art baselines. So the proposed framework is still in very early stages, but the main proposal is to have a shared embedding of the different multi-domain products into a single graph representation model, that is heterogeneous graph, that is a representation of all the different products, different items from different domains into one shared representation model, so that when the link predictions are being done, the recommendations, all the inter-domain, the multi-domain information is taken into account. That is, when we do the link predictions, we can also span multiple domains to identify a potential recommendation, a potential interest. Of course, and to improve the recommendation accuracy, attention, heterogeneous graph attention is proposed, so that for the attention will give more weights to the more important neighbors in recommendation, because depending on the behavior and scenario, some node neighbors on the graph model, they are more important. So heterogeneous graph attention model and graph transformer is proposed. And then, of course, by having those different domains interlinked, cross-domain recommendation tasks will be the main downstream tasks there, whereby we can recommend based on previous interaction between the multi-domains. For instance, based on, we can, a link prediction task can involve products from one or more multiple domains. We can infer the information from the different domains. So it's still in the very early stages. Thank you for your time. That's the main highlights on the research work. Any questions will come.
Thank you very much. I'm not sure if you could hear us clapping, but we gave you a round of applause because the microphone is here. So are there any questions? About this presentation? No? Oh, yes, there's a question.
How do you define heterogeneous? Because I see that word coming up in different contexts all the time.
So the question is, how do you define heterogeneous? Is that true? Yeah. Because it comes up in different contexts every time. Can you say a bit about that?
Okay. Oh, thanks. Yeah, it's a good question. In this case, the heterogeneous. For now, I'm working on the Amazon review data, which is text and image data. So the heterogeneous in this context will be text and image representations onto, so that will be mainly text and image to get a single unified representation of products in text and data format. Sorry, text and image format.
Okay. Any further question in the audience? Okay, then maybe we thank Tendai again. Maybe if you... Thank you very much. So Sophia is next, yeah? Screen again. Which is this one, yeah. Right. Here, yeah. That should work, hopefully.
That's it. Yeah. Okay. Thank you very much. So good afternoon, everyone. I hope your minds are still here, not thinking at the banquet. So my name is Fdia. I'm a PhD student at University of Lisbon from the LACIS research group. And I'm here to present my research topic named External Knowledge in Distance Supervision for NR Relation Extraction. So what I pretend with this presentation is more about talking about the topics of my research. Since I'm still at the very beginning, some methodologies are not very well defined. So I hope that you will help me at the end of this presentation to give me some value input. So relation extraction is one of the central tasks in natural language processing, but it depends on annotated corpora. But in the biomedical field, there is a scarcity of this annotated corpora, good quality annotated corpora. There is corpora, but good quality. So one way to surpass this is using a silver standard corpus, which is a corpus that we create in an automatic way, and we validate a subset of that corpus. This can be made by using a distance supervision approach, which we can consider two entities that are in the same sentence. If the same entities are present in a knowledge base, then we assume that there is a relation between those entities in that sentence. But that approach results in some problems. For example, the knowledge base can be incomplete, and sometimes the entities are mentioned on the same sentence, but there is no relation between them. They are just on the sentence at the same time. I have here an example that I've read so you could understand better this distance supervision approach. For example, this knowledge base with I have a relation between gene A and phenotype X and gene B and phenotype Y. For example, in the sentence, a study comprising of gene A, B, and B patients with phenotypes X, Y, and Z was conducted. Okay, so considering the entities gene A and phenotype X, according to the knowledge base, using the distance supervision method, the system will say that there is a relation. It's true, there is a relation with the system, but it isn't true in the reality, right? Because they're all, the entities are in the same sentence, but they are not expressing actually a relation. And the other error that can occur is when the second example, when upregulated the gene B leads to phenotype X. Well, in the knowledge base, I don't have that relation. So the distance supervision will tell me that there is no relation between the gene B and the phenotype X, but when we read the sentence, we can understand that there is a relation between these two entities. So this technique induces a lot of noise on my corpus. One way to surpass this is, instead of treating the sentence or instance, I would say instance or sentence interchangeably as one sentence and a label, I put them all in a bag. All the instances that share the same entity pairs will go to a bag, and I'll assign a label to that bag. So, for example, if I have a bag of sentence with a label true, at least one of the sentences in that bag has a true relation. But the systems that employ this technique, the authors sometimes say that this can be for the extension with external knowledge. So they don't use it, don't take advantage of the existing external knowledge. There are systems that take advantage of the external knowledge, such as, for example, BioOnt, which is a binary relation extraction system that employs domain-specific multi-ontology and has proven that when we integrate external knowledge on the systems, the knowledge have a better performance. For example, BioOnt performed better on the F1 score than the well-known BioBERT that is very used for binary relation extraction. And it was used on drug-drug dataset, phenotype gene, chemical index, disease relation dataset. I don't know if you are noticing, but I'm always talking about binary relations. In matter of fact, the majority of corpora that exist and the majority of systems that exist are binary relations. But there are some examples of binary datasets from the biomedical domain, but are binary relations enough? When we are talking in a biological context. For example, I have here two questions, so it's easier to understand what I want to say. For example, all gene variations impact drug response on different phenotypes. In which tissues or cellular types gene mutations lead to a specific type of cancer? Will I be able to answer this type of questions with only binary relations? The answer for these two questions is no. We need more. For example, if I want to create a biological network represent a natural system, the binary relations might not be enough because I need the context for those relations. A practical example, recent studies have found that a specific gene, when mutated on the specific tissue, will lead to a specific phenotype. But the same gene on another tissue will not lead to that phenotype. So if I want to know if the gene A, for example, leads me to the phenotype X, I need to know that context, the tissue, for example. So what I'm talking about are ternary relations. There are already models and some data sets appearing on the biomedical domain, but they are still new. And mostly they use, for example, cross sentence, because the entities sometimes, because there are three now, they are not always on the same sentence. So we need to consider other sentences on the texts. But there are still room for exploring single sentence. As we can see here, we have a gene, phenotype, and a tissue. And if we read the sentence, there is a relation between these three entities. So, having all these problems that I've been pointing, what I want to do on my PhD project is gather all these problems and all these solutions, and having as main hypothesis that external knowledge will improve the systems. And I want to identify the context and relation extraction by enhancing the recent frameworks and extract an area relation with using that external knowledge. So this is more or less the workflow that I pretend to follow. Create a silver standard corpus of gene, phenotype, or disease tissue of the ternary relations. Then create a prototype of the ternary relations using the most known methods and systems to identify solutions and challenge. Then I will go to the state of the art that will exist at the time I reach that task and try to identify, using my initial data set, what can I improve. Then the final task will be to develop a system that will integrate the external knowledge that it's my hypothesis that will improve the system and that will able to extract area relations. Thank you very much.
Are there any questions?
It's really interesting research. I'm just wondering if the data sets are majority binary relations, how can you still use those data sets for your more dimensions testing, or do you have to discover different data sets?
Okay. Right now, what I'm doing is the second option, because they are emerging some new data sets, even gold standard data sets. So I will try to use those and compare to the one that I'll create. But because there is no knowledge base for ternary relations, at the first approach, I'm treating my entities as binary pairs, so I can validate each individually and globally after treat them as a ternary relation because of that lack of knowledge base.
Yeah, but can you still compare with other people's work, like existing work? I guess the state of art, they were working on those data sets. You find out the binary data sets.
Yes.
But then, can you still compare with them, or There's no matter, we don't have to compare with that work.
Okay, honestly, I don't know if I'm thinking if I understood it properly, but we are going to use already the NRE systems with the NRE datasets. But if I see that it is advantage to compare with the others, I can, because I can set my dataset in binary relations.
Yeah, makes sense.
Okay.
Thank you.
Another question?
Ask my question. What's the difference between the NRE relation extraction from event extraction? I mean, what was the difference between the NRE relation extraction from the event extraction? You know, in event extraction, you also define my template and what the event is, and the event may have as arguments. Yeah, so can you share some insights on their difference?
About the second one is, you said it's event extraction. Event extraction. Okay, I don't know much about event extraction to provide an insight about that. Sorry, I don't know.
It might be interesting to look at that.
Yes, we can talk later because.
Any further comments or questions? Okay, so yeah, thank you very much, Sophia.
Thank you.
Next. So. Let's get rid of this one. Okay, which that one?
Yeah. Yeah, it's a PDF.
Yep, that's okay. Yeah.
Okay, great. Yeah, thank you. So, hi everyone. I am Laura Menotti, and I am still doing my master's degree in computer engineering at the University of Padua in Italy. So this is my master thesis, and it is a reproducibility study of a relation extraction system. So in this work, we reproduce this system that is called Dexter, and it extracts gene disease associations from biomedical literatures. These tools are very useful to populate databases that contain this type of information, so that we do not have to rely only on manually curated data. The objective of this project, therefore, is to provide a benchmark for future works regarding relation extraction. In this way, researchers can test and compare results of their new systems with an accurate baseline. So we talk a little bit about the system architecture. It is important to notice that Dexter is rule-based. This means that the information are extracted by matching some syntactic structures on the sentences, and to do that we use Semgrex patterns. This is the overall system architecture, and as you can see, we have several blocks that do different tasks. And in the next slide, I provide you with an example so you can follow a little bit better what each module does. So Dexter takes in input the sentence text that you can see above there. And in the first step, we take this sentence and parse it with some NLP toolkits, and we produce a standard dependency graph that is shown in this picture. This standard dependency graph allows us to read these patterns that in the next module, that is the relation extraction one, allows us to extract some relevant component for our tasks. These components are the compared aspect, that is this one highlighted in red, the level of expression, that is in yellow, and the two compared entities that are in green and blue. If we go back to this previous slide, we see that we arrived here. So we have the extracted components, but we see that the parse sentence is also taken input by this module, that is the entity detection and phrase typing module. Here we use pubtator annotation to detect gene and disease mentions in the sentence. This will be useful in the last module, that is this one, in order to check if the components we extract from the relation extraction module are of the correct type. For example, coming back to our sentence, we check if in the compared aspect we have a gene mention. If we do not, we discard these matched components. In this last module, we also extract the relevant information we are trying to get. So as you can see here, we extract the gene mention, the gene ID that is provided by pubtator, the disease mention that we found in the sentence, and its disease ontology ID and name that also comes from pubtator annotations. Then we also extract the expression level that is normalized to up or down. In this case, the level of expression is higher, therefore we normalize it to up. Dexter also classifies sentences in type A or type B. This is useful because the system was originally developed to integrate data in BioExpress. And this database has some constraints where this type of classification can be useful to differentiate which data we can integrate or not in this system. So type A sentences are comparative structures because we see that we can see in the example that the gene expression, that in this case is a nucleolin expression, is compared between two different samples that are a cancer tissue and a normal tissue. These are type A sentence, while on type B sentences, we have no explicit comparison, as we can see in this example. As far as the system is concerned and the implementation, we do not have many differences between matching the two sentences, but in the first case, we extract two compared entities, while in the second one, we extract only one compared entities. We recall this is a reproducibility study, so we needed to see if we implemented an accurate version of the system. Therefore, we use some test data that were provided by the authors of the original paper, and we compared our results in terms of sentence type and the gene expression level. So overall, we were able to parse the 97% of the test sentences, and most of the errors were due to the dependency parsing because we changed the library and used another parsing. So most of the errors were attributed to that. As far as accuracy is concerned, we achieved an accuracy of 84% as far as expression level is concerned. However, we saw that this value raises up to 93%, as we can see here, if instead of using pubtator annotation, we use the gene and disease mentions that are provided in the test data. This may be due to the fact that the pubtator is a tool that is periodically retrained. Therefore, the original paper is from 2018. Therefore, we may be using a different version than the original authors, hence we see a difference in the performance. So to conclude, from these results, we can see that the system has been reproduced to a reasonable degree of accuracy. And we publish the source code in GitHub so that anyone can run its own data or compare their system with our data and our system to see if they actually made an improvement or not in this domain. We also noticed that Dexter is rule-based, therefore information are extracted based on patterns that match some specific syntactic structures. And this could be a limitation when we deal with biomedical literature and natural language, because natural language does not follow a strict form or structure. Therefore, in future works, we may be concerned with improving this system by applying some supervised learning or distance supervision. So that is all from my side. Thank you, and feel free to ask me any questions.
Any questions? Yeah.
So the results table made me a bit scared. Like the accuracy, precision, recall, and F1 all very close together.
Yeah.
Is there something in particular going on there? So I expect it to be a bit scared.
Yeah, well, we actually used a lot of data, and I think that I don't know, I think they were very similar because they changed in the last numbers, and we actually saw that we used, as it is written here, we used 3 use cases. So we saw that in both all the use cases, the error were mostly the same and due to the same aspects. So I think that is why we have so close results. I don't know. It was strange for me too the first time I saw it, but then we got used to them.
Any further questions? We won't try it already. I have a question, maybe very naive comment, but is there any relationship to Sophia's work that she presented?
Yeah, well,
or could there be?
Yeah, maybe it could be. I don't know. I mean, it looked very related, but as Sophia was saying, this is binary relation extraction, and we have some works on binary relation extraction. I mean, as the best of our knowledge, this is the state of the art as far as gene disease associations are concerned. But there are a lot of other systems concerning other things, but. I mean, it could be because, as you saw before, we actually extract 3 information, because we extract the gene, disease, and also the level. So it's actually ternary. So maybe doing ternary relation extraction could improve performance also in this task. I don't know, but it could be interesting.
There's certainly an EU project in the making now.
Yeah.
Yeah. Okay. Any further comments, questions? So that was a master's thesis, right?
Yeah, that's my master thesis.
That's very impressive.
Thank you.
Very nice. Okay, so yeah, thank you very much, Laura. Now, next on our list are lightning talks. Lightning talks is something very ad hoc. If you have anything to present or say, even if you don't have slides or whatever, or a demo of a system or want to tell the world something that's related to IR and information access, of course. Yeah, so but no other things. But then you might just come forward. We have, I think, one talk. Who was that? You, yeah. So I think you sent me slides, right? That's one. Yes, yeah. Just.
Okay. Yes, okay. My name is Antonio, and I am a PhD student in artificial intelligence for environment at Fdia ESSIR2022 in partnership with Eni, this industry. And my research idea is just an early stage research idea that I started very recently, and it is how I can carry out information extraction from scientific papers in the context of biorefineries. The problem is that in the context of biorefineries and production of biofuels, there are no public datasets. Even during my work, I received some data on biofuels to try to find patterns, but the problem was that the size of the data was not too big. So my idea was to try to find in the scientific literature, because there is a huge amount of scientific literature. And my goal is to try to extract some information and some data from literature to create a chemical database in the context of a refinery. Obviously, I already know the variables that I'm interested in and the processes that I'm interested in. So just as an example, what I found in the papers is that the data are most in the tables, not in the free text. So, for example, this is a table about biomass. These are some variables that I could be interested in, and these are Geode, I don't know how to pronounce, and Douglas Fir are different biomass. And so the goal in general is to extract variables that I'm interested in about biomass or biofuels and extract the value to create the database. And one problem is that this is a simple scheme of the table, but I saw in the papers that there are a lot of different tables with a lot of different scheme and shape that are quite fancy. So it could be not very easy to extract information from table. What I tried to do recently is to use Science Direct API in Python that give me a flattened table. So you can read, this is only the first part is only the caption, but after you can read the flattened table. So you read the table from left to right, and you put the second row near the first, the third row near the second. So for example, you have Geode and Douglas Fir after moisture 1.93, 1.29. So you have this flattened table. And the idea is, I repeat, that is a simple scheme of a table, but there are a lot of different tables with different scheme, more complex. So was I asking to myself if, for example, I can treat this as a sequence. So since my goal is to extract information, what I could try maybe is to treat this as a sequence and use neural sequence model to carry out, for example, tasks like name identity recognition to extract the biomass that are in this sequence, and after to carry out some tasks like relation extraction to extract the triplets biomass variables measure. So I'm here in the Latin talks only to speak just about this idea. It is only an idea that I was studying. So now I am not results. And I'm here only for suggestions. For example, my question is, in your opinion, does it make sense to treat a table as a sequence, or I should find other alternative? For example, download the XML papers and try to scrap XML files to extract data, or to use other approach to reach this goal, this kind of goal. And that's it.
Does anybody have any comments on this?
can I ask what do you want to use this collected data for?
Okay, there are a lot of open questions about from the side of chemical engineering about biofuels. So the idea in general is to have a database, a great database about some with variables about biomass, variables about the biofuels that are produced from this biomass with some processes. And so the goal is only to have this great database to try to find patterns in this dataset, to try to ask some research questions, because in this moment chemical engineering has a lot of research questions about these processes. For example, which are the value of some elements of the biomass that can produce a better biofuels, something like that.
So you need a context with the table as well, because I guess when they presented the table in the literature, they were perhaps structured differently and maybe a description around it to talk about what the table is actually talking about.
The table before it was only on, for example, on biomass, and it is not, for example, if my first stage is to collect only table on biomass, I can extract from the papers on all the tables, and I can try from the caption to extract only the table that are related, for example, on biomass. But after, even since the table, this is a very simple table, but there are other tables that are more complex. It is not easy to extract this information. So after I had to try a way to automatize the fact that I had to extract this data, especially from the data from the tables, because there are less data in the less information in the free text.
Okay, the reason I'm asking what you use it for, because in the past I worked on a e-learning project. We were trying to recommend learning materials, like even recommending literatures, scientific literatures to students who's learning a particular subject. So what we did is to actually extract the tables and figures into images rather than reading them into like texts, like this script you're showing on the bottom, and to compare the similarities of them and then to find out whether they are related literatures. So, but that was for a purpose of.
Okay, just was a recommendation on the. Okay, understand. I was thinking to, since I know what I had to extract, but the papers are a lot, are thousands of papers. Maybe I am trying to find an automatic way to extract the data on some concept that I already know. That's all.
Thanks.
Before I start, yeah, I have a comment. So on the next slide, you mentioned XML.
Yeah.
So how severe is your problem? I mean, is there too much literature available that's not there in XML, or because when you say the alternative would be download XML, I mean, if I have them all as XML, then your problem is solved, right?
No, I mean, I was trying only to work on. I first downloaded with this API all the papers as string, and I have this flattened table. But maybe I was wondering if just my question, for example, is if I can treat I can give as an input to the neural models to extract the information, the table as a simple sequence, or maybe it is better to work on the XML. Since I know that there are people that work on XML and use tag to try in some way to parse XML and extract data, so maybe it is better to work in a real basic way, working on this XML format.
I mean, normally I would have said, yeah, take the XML and it's done, but of course it could be that a lot of literature is not available in that format.
Yeah,
in that case, your approach would be necessary.
Yeah, no,
and you
I know.
might use the XML maybe to train some model, yeah, but because they have a gold standard here maybe, but so yeah, it depends on what is your actual topic. I mean, if you want to just use this for a PhD and you have an XML database already, then you might just use that. But you might make it your PhD topic to really extract tables, which might be research in its own right, of course. People tried that, parsing tables. It's a thing that they also do for a while now. And so in that case, of course, then the XML would only help, as I said, to train maybe, but that's the only thing. It depends on what your actual topic is, I would say. And that defines how severe your problem here is for your work. Yeah.
Yeah, I mean, in this moment, the problem is that I need to collect data on this topic on biofuels because there are not at all public data set, or there are some only both sides data set. So now my goal now is try to automatize some way to extract information that they need from papers. So that's it.
Any further comments on this one? Yeah, thank you very much. So, anybody else wants to tell us something?
Or ask a question if you have any questions regarding on your research, or you want to get some advice from everybody. We will try.
Any comments? Then we will ask. So, okay, if you don't have questions, I have questions. So, my question is, how did you like the session? Okay, thumbs up, okay. So what would you do better? What do you think worked well, apart from technical problems and so on, but of course, and any?
Very quick thoughts going around the room. I feel there are not too many senior members. In the first half of the day, I had a lot more seniority around.
Yeah.
And although it would have been intimidating if they were all here in the second half, I think it would also be pleasant.
We have some here, yeah. So
yeah. Appreciate it.
That's a bit of a known problem, yeah. It's, because the idea of FDIA is to kind of do what we call in higher education a flipped classroom, yeah. So it's so you more or less tell us a bit, because the whole summer school is about the other way. Yeah. It's, I personally find it very interesting to see what you're working on, and also how it a bit relates to the talks that you hear in the summer school. And I hope a lot relates to that. And so I'm really curious also how it all works out for you, yeah, your ideas, and yeah, it's very interesting. I mean, it's called Future Directions in Information Access. So that means we talk about problems that hopefully you will work on for the next years. Yeah, and then maybe some of you will end up in academia and have your own PhD students, and they might follow up on that, or something completely new. And so yeah, that's the idea of the whole thing, yeah, this dialogue and interaction. And because we are also curious, I mean, you have all these, you know, important persons and famous persons who give you foundations and some more specialist talks, and you might think, wow, they're doing all this cool stuff, but they're also interested. Well, I guess they're interested, but some of them are not here, but but they're still interested in what you're doing. I mean, they have PhD students themselves, and I think research and science is about dialogue. It's about interaction and speaking, and so that's one of the ideas that we have with FDIA, and that's why we placed it explicitly at this summer school. And also to tell you, well, yeah, we might be seniors, but we were there where you are now, yeah, and so you will be here one day, maybe running FDIA or giving a talk in the summer school and whatever, because you are the expert, yeah. So don't be shy, yeah. You're equal in a way for us. Yeah.
Okay, so for the seniors, if you could go back to your PhD phase, which things will you do differently?
That's a good question. Does anyone, Nicola or Jaime, have any comment here?
Specifically for the PhD, so personally, I didn't go a period abroad or another research group. It doesn't mean, let's say, my career path, but I think that is available experience to be done. In the culture of the you see, as another group works, there is a different team, and it's somehow energizing. You also step back a little bit from your, let's say, daily project, and to have a plan, so not to go there just for tourism. I come and visit you, and then we will see what if we can do something together. That is a bit too much, but it doesn't need to be too focused or exactly the same track on your main PhD problem. You can also pick something around just new ideas and new skills. Also because just after the PhD, you can enlarge a little bit your research statement. Okay, you are super cool on that field, but then you start also to do something different. So that visit can be starting point. Other things, this is not maybe exactly during the PhD, because it depends a little bit, but it also depends on the countries. For us in computer science, and especially information retrieval, conferences are the most important thing. ESSIR first, and ESSIR for Europe, etc. So this is where you get evaluated by the community, where you get in touch with your peers, where you learn the stress of presenting in front of 100, 200 people, which is very different from presenting on Zoom or remotely. And this is the first focus. But you have not to forget that those journals are very important. Maybe not much in the US, etc., but in Europe, in different degrees in different countries, they are part of the world. And the journals have the problem that they don't have deadlines. They require more work in some sense, but they don't have deadlines. So people rushing for the deadlines of the conference, so all project work, etc., and to postpone journals. But journals are a very long process, because from the day you submit to the day it is actually published, could take on average 1 year or 8 months. So that is something that you should always have in the background. It's not that you have to do 10 journal papers per year, which is not feasible, but you should have also a kind of continuous pipeline, because you need to have a couple of them in work in progress, reviewing that because it takes time and it's something that needs to be done continuously, especially for this sort of
If I may add something, sorry, because Nicola, that's a good, what you said about interaction and visiting others. Yeah, I mean, I have that in my PhD, and funnily, I visited Nicola in Harvard for 3 weeks, and when I did my
my supervisor when we were doing the PhD more or less.
I mean, Nicola and I will work on this more exotic topic using annotations for information retrieval and digital libraries, and there wasn't much choice to visit other persons. He was the obvious one, and but what I learned there was because I had this fancy approach, a logic-based approach, and in Norbert Fuhr's group where I did my PhD, we had this probabilistic data log, which is a probabilistic variant of data log, similar a bit to Prolog, if you know a bit about logic-based programming and stuff. And so for me, it was completely normal that my approach is based on that. So I went there. They said, "Oh yeah, I give a talk about your work." So I did that. I said, "Yeah, probabilistic data log," and then the first question almost knocked me out. Why are you using probabilistic data log? For me, it was so normal to use it because everybody used that in Norbert's group at that time. But that's of course not the answer, because that is a question that could also come from your PhD examiner later. Yeah, and to just go to an environment that has a completely different perspective on your solution, that was so helpful for me, I have to say. Yeah, it was really a very good experience. So if you can do that, if you can interact with other groups, give presentations there, maybe they invite you and so on, I think that's super helpful. Okay, there was some.
Also, if PhD is important, it's fundamental, but it is not all. It is something that you need to keep a balance. I think one of the worst errors you can do is to burn out for a PhD. It's not really worth, and it's not needed. Basically. Probably it works much better if you keep a work-life balance with your interest, your spare time, because you have fun. You are a human being, so you need everything, and that also enriches you. And at the end of the day, you are much more clever and productive in your research. It's not that if the PhD becomes your whole life is a good thing. It's possibly something wrong. And in that case, talk with people, with your peers, if you are not the supervisor, with your supervisor, etc., because it's something that can be managed and
okay, so there were some, yeah.
Yes, if I understood the very first advice correctly, it was a suggestion to not just work isolated at a PhD, but also reach out and maybe contact other research groups and all that. So do you have any tips on how to do that? How to actually, for example, get people to go as far as collaborating with you?
That is partially duty of your supervisor to create opportunities to collaborate, to get links with other groups. The other thing is the events, which was really possible in these 2 years, but the real motivation for us to make us exchanging ideas and progress research is that we understand, okay, so you do this, and I know that you do this, and we can work better. And don't be, let's say, shy and be part of it. It's not that if you go to another researcher or a senior researcher and say, oh, I see that you work on this, is there any chance for me to visit you? That person would be upset or would consider this too much or inappropriate behavior. It's really talk is not possible.
Yeah, I agree. Just to add to what Nicola said, to attend this event is also a really good way of expose yourself and socializing. Even if you don't give a talk, just be here, you learn a lot. Because my PhD, the first year, I was doing something completely different. So towards the end of the first year review, I came to a bottleneck. Basically, feel like, oh, where do I go next? So I attended a summer school. So from there, what I learned, I didn't even give a talk, I just really just attended and talking to others and listened to others. And so I changed my PhD topic almost completely afterwards. But I managed to get it done on time because that was something I find that I'm interested in and I feel like I'm comfortable doing. So yeah, to attend those summer schools and talking to people, it may not seem to be a lot, like we are here talking or know enough seniors, for example, only very fraction number of PhD students here from worldwide doing information retrieval. You are only very small numbers of us here, but you are learning, you know, it's very good for you to attend it. And also to know Laura, who is only a master's student and who's here already. I wish I was in the summer school from day one of my PhD to know more about IR and the field and people, what people are doing.
Comments?
Not necessarily an advice, but then just wanted to reference Jimmy Lin as Professor Jimmy Lin has a web page on GitHub where he writes up stuff about doing a PhD. If you just Google the student's guide to Artiling 2, you'll see most of his write-ups on doing a PhD with him. So I think he has pretty good advice there as well.
Yes, with a little bit of care, because Jimmy is very much be the first or die. So like you need to put it out on archive at midnight because tomorrow at midnight or one someone else will put that out, etc. It could be true to a certain extent because especially on certain topics like neural, etc. There is a lot of competition and there is a lot of preprint and whatever. That's good. But maybe it's not the only way to think things. Okay, so I mean, all the things that we say, and Jimmy is a super good researcher, extremely effective in getting to the point. So there is no criticism here. But what I would like to say, okay, whatever suggestions, thing that we say, don't take it as a gold standard. It's not the track CIA assessors that are God and that's it. Just take it in a relative way and try to contextualize to your own experience, and especially if this is what you want to do. The simple fact that all the others do it that way or that is the most typical behavior doesn't mean that you also need to do so.
There's no one size fits all. Yeah.
Yeah.
It's true. It's a good comment. Yeah. Further. Who of you knows Karen Spark-Jones? Sorry?
I had that name in David Hawkins' book.
So you should definitely look her up. Yeah, one of the founding mothers, more or less, of our field. Yeah. And I remember I went to a conference, it was a digital library conference, and she was there. she passed away some years ago, but and okay, I wanted to ask her about my topic, what she thinks about that. I mean, she started doing IR in the 50s, and I was so nervous. And I gave a talk at that conference. I was kind of glad that she didn't sit in the audience and would tell me all my ideas are what we did 30 years ago. Yeah. But yeah, lovely lady. So really, and when I spoke to her, she was so nice. Yeah, and I was nervous. She was nice. It was yeah.
You mean ESSIR in 2003?
Yeah.
Because Karen had she typically was sitting at first row, the whole conference, every talk, she was doing the questions. So
she could always say something. Yeah. So you have 50 years combined experience sitting in front of you, and you have 5 months combined experience. and right, but she's nice. She was nice. Yeah. So, if you have anybody to recommend for the Terence Park Jones Award, which I'm sending, you know, where it's an award for, I think you have to for PhDs, but within 10 years of after their PhD, you know somebody to nominate for that, yeah. But that's a different story. Just Karen was active in IR and in NLP, both communities, and a great role model. So,
yes, check it out on our BCS IRSP website. We run this young early career researcher award, basically, not during your PhD, straight after your PhD, between the first year after your PhD to the 10th year, you can be nominated.
Or nominate somebody else.
Yeah, or nominate somebody else who knows that eligible for that.
Anything else? Any comment, question, remark, criticism? Or just telling us, can you finish now? All right. So maybe you should just do that. So yeah, thank you very much all for being here. It's really a great pleasure to have you all. Sorry, story of my thing. Smile. Okay, thank you. Yeah, it was a great pleasure, and yeah, I hope you could take something home from this note, of course, from the whole summer school, and you can stay in touch with us if you want. Know our email, our names now, and if there's anything that you would like to tell us or need some advice later in your career, we certainly are happy to speak to you. So, great pleasure. It's always a great pleasure. You all know where to go to the banquet, right? I hope.